All right, so today we're going to take a look at 2.4, which is on solving linear inequalities. So yesterday we solved linear equations. The only difference today is you're going to replace the equal sign with one of these four symbols. Less than or equal to, greater than or equal to. And those are both examples of inequalities. Okay. 3 is less than 8. And 3x is greater than 12. This first one is an inequality that's a true statement. This second one is an inequality where you'd have to solve it to get x by itself. And there is one extra thing that happens when you multiply or divide by a negative. Something you have to do to the sign, and we'll write that down when we get to it. So if you want to check if a number is a solution to an inequality, you take the variable, you replace it with the number you want to check, and then see if that results in a true statement. So let's say I wanted to check if 5 was a solution in that inequality that has the blue box around it. I would plug 5 in for the variable and see if I get a true statement. So let's try it. Let's plug 5 in for x. Francesca, if I plug in 5 for x, what do I get?
15.
I get 15. Yeah, 15, and then greater than 12. Is 15 greater than 12? Yes. So 5 is a solution. If I check 2, 3 times 2 is 6. 6 is greater than 12? No. So that means 2 is not a solution. Big difference here when you're solving an inequality. It's not like an equation where sometimes you have one answer or 2 answers or 3 answers. There's an infinite amount of answers to this. In fact, it would be any number greater than 4. And don't just think integers. Be like, oh, greater than 4 has to be 5. No, it could be 4.006. That's greater than 4. So any number greater than 4. So any question on how to check if a number is a solution to an inequality? Okay. So one type of inequality we can have is what's called a conjunction. A conjunction is really two inequalities, and you put the word "and" between them, like this. X is greater than -1, and x is less than 3. Now, a lot of times when we have a conjunction, we can shorten this, and usually people do. This is how you can shorten it. So you can actually make it so you only have to write the variable once. You don't have to write the word "and." The word "and" is still here, but it's invisible when you shorten it. The way you'd pronounce this is, x is greater than -1, and x is less than 3. I mean, you could also say -1 is less than x, and x is less than 3. It's the same thing. And if you're kind of looking at it, this is right there. X pointing at -1, x pointing at the -1. And this, x pointing at 3, is right there. X, and then it's, x, and it's pointing at the x, and then a 3. Another way you can combine these into one is you could do this. You could put the x in the middle, put a 3 on the left, and you could put the -1 on the right. You could switch the numbers. But what else do you think you'd have to do there if you wanted to write it that way? Yeah, go ahead.
Flip-flop the sign, so on the left there would be the greater than sign, and on the right it would be less than.
A greater than sign like that?
Yeah.
And then what about here?
Less than.
Like that?
No, but a greater than sign.
Greater than sign. Whenever we combine two inequalities that are a conjunction into one, they do have to point the same way. And they always have to point at the smaller number. Okay. I don't normally do it this way. I usually like to put the small number on the left, bigger number on the right, which means my inequalities will always point left. It's possible you could have something like this, where it's basically you have one that has the equal to and one that doesn't. That's fine. Okay. But any questions on how to take two inequalities and combine them into one? I think in the homework you might see a question where you have to take something that's all together as one and split it into two. And that comes up when you're solving inequalities. So this is what we call a range. Okay, we're saying here that x is basically any numbers in the interval from -1 to 3. And this is an example of what we call an open interval. An open interval means that you are not allowed to include the endpoints in the answer. So think about like an open circle. You put an open circle on -1 and an open circle on 3 and shade between. Open means do not include the -1 or the 3. So we're going to talk about a few different terms. We talk about what's called open and closed intervals. And we're also going to talk about bounded and unbounded intervals. So a bounded interval is an interval where it has an end to it. It stops somewhere. There's an actual number that you can say, here's the beginning of my interval, here's the end of my interval. Can anybody think of a symbol that we use in interval notation that would represent an interval going on forever? Not stopping. Yeah? Yeah, the infinity symbol. Okay, that's different. If you put an infinity symbol as one of your bounds, that's what we call unbounded. It just keeps going. There's no end. But bounded means the interval stops at a number. Whether you include the number or you don't include the number, that's determined by what we call an open or a closed interval. Okay, that's a little different. So this is how you would write a closed interval. Bracket on the left, bracket on the right, and put your two bounds as first number, comma, second number. You always have to write an interval the same way you would write like a window. This is always the low value, the A. The B is the high value. So it's always low, comma, high. This is an example of an open interval. This would be like what we have up here, from -1 to 3. Don't include the -1, don't include the 3. Now I mentioned that there were 4 types of bounded intervals. We've got closed, we've got open. Anybody think they know another type besides the 2 I have right there? Yep, Ashley.
Would maybe one be like one of the brackets and one parentheses?
Yeah, like half and half. So we can have a half open interval. This would mean you're allowed to include the low value, but not the high value. So if you're like, well, what would that look like as a graph? It would be kind of like this. Here's the low value. Here's the high value. Closed circle on A. Open circle on B. Shade between. That's what that one would look like as a graph. I'm not going to graph all of them, but I'll graph a couple. This bottom one is also a half-open interval. This time, you are not allowed to include A, but you are allowed to include B. So we can have a fully open, a fully closed, or half open, half closed interval. Any questions on the 4 types of bounded intervals? Okay, so bounded means you always end up shading between. With an unbounded interval, the shading has an arrow indicating that it keeps going forever in a direction. So these are all examples of unbounded intervals. Let me graph the one in the upper right. This would be a closed circle on 5. That's my lower limit. And this time I can include it. And my upper limit is infinity. It means it just keeps going. And the other intervals are just different combinations of that. Open circle with an arrow right, closed circle with an arrow left, open circle with an arrow left. Okay, these are what we call unbounded intervals. So unbounded means it has infinity. Bounded means it's a shade between. You have 2 numbers. Any questions on what an unbounded interval is? Okay. So let's see if we can take something that's written as an interval and rewrite it as an inequality. So what I want you to do is take something like this and rewrite it more like that. First of all, let's just describe what kind of interval is this. Is this bounded or unbounded? Francesca?
It's not the unbounded.
How come?
Oh wait, no, it's not. It's the bounded because it's bounded.
Yeah, it's bounded because you don't have an infinity symbol. Infinity is the only way to have unbounded. So it is bounded. And what type of interval, what type of bounded interval is it? Is it like open? Is it closed? Chris, what kind of interval is this one?
Say half open.
Half open. Or if you're pessimistic, half closed. It's half open. Now, how would we rewrite that as an inequality? Anyone think they could tell me how to do that? Well, how about, can anybody tell me, what does this mean? Like if I said to you, you could pick any numbers described by this. How would you explain to somebody what that means if they had never seen something like that? Yeah, Jake?
The number that I have to pick, it has to be greater than -3, but less than 5. Or less than equal to 5.
Less than or equal to 5, yes. Now, could you kind of just you almost said it, but could you translate what you said into an inequality?
So
Use X.
be -3 is less than X, and then X has to be less than or equal to 5.
Yeah. So there's your inequality. It says x is greater than negative 3 and less than or equal to 5. Perfect. You could also write it exactly the way I just pronounced it, with the word and. But this is the short way. All right, how about this one? So first, Abigail, is that a bounded or an unbounded interval? Unbounded. Right? Unbounded, half open. Half open on the left. So could someone else describe to me all the numbers represented by that? But I'd like to describe it as an inequality. Oh, Ethan?
X is greater than or equal to 4.
Can you say it again?
X is greater than or equal to 4.
X is greater than or equal to 4. Not quite. You're close. Okay, Chris?
X is less than or equal to negative 4.
No, we were closer before. So,
X is greater than 4.
no. I'm not sure where you're getting the 4 from.
Oh, negative 4.
Negative 4, yeah. X is greater than or equal to negative 4. That's a negative. And that's it. X is just greater than or equal to negative 4. Some people have said in the past, nobody said it this time, X is greater than or equal to negative 4 and less than infinity. You don't have to tell me X is less than infinity. I know every number is less than infinity. So all you have to do is say X is greater than or equal to negative 4. All right, and let's try this one. Okay, Zach, is that bounded or unbounded?
Bounded.
Yep, bounded. And Tyler, is that open or closed?
Closed.
Fully closed, bounded interval. Yep. How would we describe the numbers that you're allowed to pick as an inequality here? Tyler?
-8 is less than or equal to x,
Good.
which is less than or equal to -3.
Perfect. So that says x is greater than or equal to -8, greater than or equal because we got the bracket, and less than or equal to -3, equal to again because we have a bracket. Anytime you have a bounded interval, you always have to describe it this way. The two numbers and the x in the middle. Okay, questions on that? So now let's try it a third way. So we've practiced writing things as intervals, we've practiced inequalities. Now let's just take and change this inequality into a graph. So you'd have a number line. On Edge Elastic, it'll already be numbered for you. And Casey, what's the first thing I want to do to graph that?
2.
Can you say it again?
Mark 2 on the number line
And how would you mark it?
with a solid dot.
Yeah, you put a solid dot on the number 2. You could also use, does anyone remember the other symbol we could use besides a filled in circle? We don't use this one as much, but we actually just used it in the notation we did before. Yep.
A bracket.
A bracket. So you could do a bracket on 2 or a circle. We'll do a filled in circle. And Francesca, what do I do from there?
You're gonna bring it to the right.
Bring the dot to the right?
Yeah. Oh, no,
Okay.
I mean like leave it on 2, but like make a line.
Oh, okay.
Yeah.
Oh, difficult person I am. So, we open closed circle on 2, shaded to the right. And that's it. Okay, so unbounded, make sure you always put an arrow. Let's take a look at another unbounded. All right, Abigail, what kind of symbol would I put on this one? And what number would you put it on? I agree. Open on 5. And Jack, what else would I do?
Arrow go to the left.
Arrow going to the left. Again, another unbounded interval. This one's a little different. Okay, so Chris, let me number this for you. What's the first thing you would do here?
A closed dot on -1.
Okay, we're going to do closed dot on -1. Zach, what else would we need?
Open dot on 3.
Open dot on 3. All right. And Tyler, where would I shade?
In between.
In between. Remember, this is bounded. It's always in between. And there you go. Any questions on that one? All right, so you just have to look at how they want you to write your answer. Do they want a number line, like a graph? Do they want an inequality? Or do they want an interval? 3 different ways of doing the same thing. Now, when we're solving inequalities, we're going to look at regular inequalities first, then we'll look at absolute value inequalities. But when we're solving any type of inequality, there's one extra rule that comes up, and it has to do with multiplying or dividing by a negative. Does anybody remember what you have to do if you multiply or divide by a negative number in an inequality? Sarah? You have to flip the sign. So if you multiply or divide, the same thing about adding or subtracting. Only if you multiply or divide by a negative, you must flip the inequality sign. So we'll try an example. First, it's just a basic inequality, and then we'll do one like we did yesterday with absolute value, which is very similar. It involves splitting it into 2 problems. We'll look at that next. Let's try this one. So 3, and then in parentheses, x minus 1, close parenthesis, plus 2 is less than or equal to 5x plus 6. All right, so how about Jake? What would be my first step?
Distribute the 3.
Can you tell me what I get when I do that?
3x minus 3 plus 2.
Yep.
And then 5x plus 6.
Yeah, the rest just stays the same. All right, so we did that. We got some like terms we can combine. So let's take care of that. 3x minus 1. All right. Now, when we're solving an inequality, the way we generally like the answer is like this. Letter, symbol, number. Okay, same thing I did here. Letter, then a symbol, then a number. Okay, that's the pattern we want. So generally you want the letters on the left. So Bailey, if I want to get letters on the left, what would be my next step? Okay, so yeah, we can add 1. We're going to do that. And now, how would I put all my letters on the left? Yeah, it's good to do both of those at the same step. okay with that? So now you've got negative 2x is less than or equal to 7. And Ashley, my last step.
2 divided by negative 2.
Good. Divide by negative 2, which cancels that. And she said flip the sign, which is perfect. And we get negative 7 over 2. Doesn't matter where you put the negative. I usually put it in the top. So x is greater than or equal to negative 7 halves. Any question on that? All right, so now let's take a look, before we do absolute value inequalities, that's what we'll finish up with. Let's look at how we could solve an inequality on the calculator. This is good if you get an inequality that's too complicated to do with algebra. And there's actually 2 ways you can do it. One way is similar to how we calculate roots, or similar to how we would solve a quadratic. Get 0 on one side, and then calculate a root. Once you calculate the root, you're going to know where the graph is exactly equal to 0, because the root tells you where it crosses the x-axis. That's where it's equal to 0. Then the question is going to be, did they want to know where you were greater than 0? If they did, you're going to be looking for where the graph is positive. Or did the original question ask you, where are you less than 0? If it's less than 0, you're going to be looking for where the original graph is negative. So you're going to be looking for either positives or negatives in the final answer. So let's do this one. So it says get 0 on one side of the inequality. Francesca, what can I do on both sides here to get 0 on one side?
Subtract the 2.
Subtract the 2. Now, look at what this question is asking. Where something is less than 0. Less than 0. I'm going to be looking on my graph where something is negative. I want to know where it's less than 0. So, let's put that in, and then we'll calculate the root. So,
I apologize.
all right, so I typed in 4x minus 3. I hit graph, and now I'm going to do second calc option 2. That's how you calculate the root, or the 0. So we pick a point that we know is to the left of the root, hit enter. Pick a point you know is to the right, hit enter. And the guess doesn't really matter because it only crosses the x-axis in one spot. So, if you did all that correctly, your calculator should say this. There is a root at 0.75. Now, we want to plug in x values into this formula that result in an answer less than 0. So what I want to plug in values less than 0.75 or more than 0.75. Yep, Ethan.
Less.
Less. Pick a number more than 0.75. Try plugging in 10. 4 times 10 is 40. 40 minus 3 is 37. 37 is not less than 0. So plugging in numbers bigger than 0.75 doesn't work. We want numbers smaller. If you want to check a number smaller, an easy one is 0. 4 times 0 is 0. 0 minus 3 is negative 3. Negative 3 is less than 0. All right. So So we want to plug in numbers that are points less than 0.75, which will result on an answer on that part of the graph, on the red part. If you pick a number greater than 0.75, you're going to be on the blue part. The blue part is above 0. They don't want above 0. They want below 0. So it's the red part. So x is less than 0.75. And that's method 1. So the only downside to method 1 is we had to rearrange it to get 0 on one side. Method 2, you don't have to rearrange it. Let's do the same problem again. You put what's on the left in y1, put what's on the right in y2. This isn't going to involve looking for a root at all, because we don't have 0 on one side. So let's put 4x minus 1, and that'll be the blue one, and 2 will be the red one. So that's the red one, that's the blue one. What I'm looking for now is where the red graph is less than the blue graph. That's what I want to know. So let's hit graph. Look for where the red graph is under the blue graph. Well, there's definitely... Oh, did I reverse the colors? 4x minus 1 was the blue one. I'm sorry. 4x minus 1 is the blue, and 2 was the red. So look for where the blue is under the red. What do you think I'm going to have to calculate in this one? Yep.
The y-intercept or the intercept point?
Yeah. You want to calculate the intersect point. And then your answer is either going to be everything below or everything above. Depends which one you want, above or below the other. So let's do second calc, intersect. Blue, red, guess. And look at what it tells me. It tells me that they intersect at 0.75. I want to know where the blue is less than the red. So where is the blue graph under the red graph? Would that be x values below 0.75 or above 0.75? Yeah.
Below.
Below. If you pick a value, let's say of -1, and you plug it in on the red graph, you get that. If you plug -1 in on the blue graph, you get that. The blue graph is definitely under the red graph when x is -1. And it will be for every x value below 0.75. If you pick values above 0.75, then the blue graph is going to be on top of the red one, and that's not what they want. Okay? So that's a way you can solve it with an intersect, and the first way you could solve it was with a root. All right, so last thing before we look at absolute value inequalities. So this is what we call like a double inequality, or you could also call it a conjunction. You've got a variable in the middle, and you have a left, and you have a right. Now, I will warn you that sometimes when you have an inequality like this, you need to split it apart. Okay, you can't always do the way I'm going to show you how to do this one. Sometimes you have to separate that as one problem and separate that as another problem. That usually happens when you have variables in more than one spot. This one doesn't. Only has a variable in the middle. So if I wanted to solve this one for x, all I'd have to do is divide by 2. Here, here, and here. So whatever you do to the middle, do to the left and do to the right. Let's try this one. This one is going to have 3 steps. Anyone think they could tell me what I want to do first to start to get x by itself? Yep.
Divide everything by 3. Or multiply everything by 3.
Multiply everything by 3. So times 3, times 3, times 3. Now, did I just multiply by a negative? No. So we're okay. If we multiplied by a negative, we'd be flipping the signs right now. But we didn't. So multiplying in the middle by 3 cancels that out. Now we have negative 9 is less than 2x plus 5, which is less than or equal to 15. Casey, what would my next step be? Yep, we want to get the 5 out of the middle. And how would you do that? Yep, good. You want to subtract it. Minus 5, minus 5, minus 5. That's gone. Negative 14 is less than 2x, which is less than or equal to 10. And Zach, what would my last step be?
Divided by 2.
And is that a negative?
No.
Nope. If it was a negative, we'd be flipping the signs again. But it's not a negative. So we don't. So we get negative 7 is less than x, which is less than or equal to 5. Okay. Any question on that? Let's look at the last thing. So, last thing is solving an absolute value inequality. Very similar to solving an absolute value equation. Step 1, get the absolute value expression by itself. You have to isolate it. Then, split it into 2 problems. This step is exactly the same as yesterday. The first problem that we split it into is the same as the original, except just take out the absolute value bars. Now the second one, we had to do an extra step. Does anybody remember yesterday when we did absolute value equations? We took out the bars, and what else did we do to get the second problem? Ashley?
I was meant to be right, but when you switch the sign,
So,
you have like the positive and negative, one gets positive, one gets negative.
so yeah, what we had to do yesterday was we took out the bars, we made the number on the side the opposite. So if it was positive, we would have made it negative. If it was a negative, we would have made it positive. And with inequalities, there's one extra step. So we're still removing the bars. We're still changing the sign of the number on the other side. But that's the new step. you also have to flip the sign. Now, when we had two problems yesterday, this is how you always wrote your answer. X equals, and then you'd have something, or X equals, and then you had something else. So yesterday, we always used the word or. Today, we have a choice. It's either going to be this or this, this and this. Okay, it's going to be one of the two. And the way we can tell which one it's going to be is we have to look back at the original problem. If the original problem has a less than, or actually let me pronounce it this way, less than, no, I'm saying it a little weird, but it might help you to remember it, or less than or equal to. Okay, think of that as less than. Less than is an and. This bottom one here is greater than or equal to. But if you pronounce it greater, think of it that way, it's greater. Greater uses or. Less than, greater. Greater. That's how you decide whether you put an and or an or in the middle. And honestly, I do this first step right away. I just look at the problem and write down what word I need. Alright, so let's solve this. I don't think I'm going to graph it, but let's just try to solve it. Absolute value of x minus 3 is less than 3. Right, so Ethan, first step, isolate the absolute value. Is it isolated?
Yes.
Yes, then we are ready to split it into two problems right away. Before I even split it, let's just write down if it's an and or if it's or. How about Jake? Is this one an and or an or? And. Less than. Right? Less than. When it's an and, that usually means shade between. Okay, so we're going to end up with shade between. Can anybody give me my first problem that I would split this up into? Zach?
X minus 3 is less than 3.
Good. So the first one, that's the easier one because all you have to do is take away the bars. You don't have to do anything else. Now the second one, you've got to take away the bars and do two other things. Yep, Bailey?
Would it be x minus 3 is greater than negative 3?
Yep. So we still take away the bars, but she flipped the sign, that's extra, and she made the number on the other side the opposite. That was also an extra step. And now solve. So x is less than 6, and x is greater than 0. X is less than 6 and greater than 0. And it's always good, just think about that in your head, see if that makes sense. Can you pick a number that's smaller than 6 and bigger than 0? Yeah. 2. If you end up with something weird, like pick a number that's less than 0 and bigger than 10, you can't have something smaller than 0 and bigger than 10. You made a mistake. Okay. But that's how you solve an absolute value inequality. I'm not going to go through and do this whole problem. I just want you to tell me one thing. Would this be an and, or would it be an or? Chris?
Or.
It would be an or. We'd split it into two problems and do it as an or. Last one. So it seems at first like this could be a little tricky, but if you just think about it, it's not really that bad. I'm going to show you how I think about it. This is a fraction. They want you to divide two things and get a result greater than 0. So in terms of positives and negatives, can somebody tell me how can you divide two things and get an answer greater than 0? If you had a what divided by a what? So basically asking, like, what's the rule for division? When do you divide and the result is positive? Yep.
You have a negative.
Okay, you could have a negative divided by a negative. That would result in a positive. Or, what else could you have? Yeah? A positive over a positive. Now, only one of those two situations here is even possible. One of them is impossible. Can anybody tell me which situation we have to have in this problem? Chris?
We have to have positive over positive.
It has to be a positive over a positive. Why is this one impossible?
We don't have a negative number in the denominator because it makes the value worse.
You're never going to get a negative number in the bottom. So the only way to get a result here that's greater than 0, if the bottom is always going to be positive, then the top has to be positive as well. So all you have to worry about is the top being greater than 0. And that's it. Just worry about the top being greater than 0. So as long as you pick a number bigger than -3, I don't care about the bottom. The bottom will take care of itself. But the top would always come out positive. Now, is there any number that is greater than -3 that you should not plug into the bottom? Yep. 2. So we should say that. Yes, you can pick any number that's bigger than -3 except 2. Because if you plug 2 in, now you just divided by 0. That's a whole other problem. So that is important to know. And that's solving regular and absolute value inequalities. All right, so homework tonight, just on page 108. So it kind of jumps around a little bit, but I'll leave that up on the board, and I'll put the video online right at the end of class. And also just a reminder that with the assembly on Friday, we'll do our test on Thursday. So the goal is to try to finish up everything for the week tomorrow.